Okay, continuing on. Example 5. Describe the region of R3 represented by the equations or inequalities. If I have to say y equals 3, how would that look like? My graph would look like, I'll go on the y-axis, and I'll move 1, 2, 3, and I'll draw a plane since there are no x and no z, and it looks something like this. Of course, that's an infinite plane. I have graphed this, of course, on GeoGebra, and it looks like this, much nicer. But just to get an idea, of course, you should practice graphing this by hand. That's really what counts. What if I say y is less than or equal to 3? What do you think is going to happen? Well, that would mean I am going to go on the y-axis still. 1, 2, 3. I'm going to really sketch the plane. The key is making it kind of a parallelogram, right? And it's going to shade to the left. That's really going to be half of a space. Kind of half a space to the left. And if I was to copy this graph again, it would look something like that. GeoGebra cannot sketch inequalities, at least not yet. And if I was to say z squared equal plus or minus z equal, oops, wrong color. Z squared equal 9, that indicates that z equals a 3 or a negative 3. And there, I would draw a plane and another plane. Let me get the graph for that. And there it is, using GeoGebra. Now if I move to the next batch, z equal y. Well, z equal y, remember, that's like y equal x. So I'm giving this more space. I saw there's a need for that. So if I want to sketch, again, I'm just focusing on the y and the z, and I'm looking at a line that cuts at 45 degrees, literally like this. And that's going to come out and in because there's no x. It's hardest to sketch something coming out or into the board or the paper. It looks more like this. This is a much better graph. You can see it better. So it's kind of look like this. Again, I don't expect you to become an expert grapher. It's important that you visualize this more than anything. And what if I wanted to look at something like z squared plus x squared equal 9? Well, there is no y in this case, so I know how this is going to go. This is going to move 3, a circle in the x, z plane, and this is going to expand along the y because there is no y. And the graph of that looks like, and again, let me get that for you. And it looks like this. Now, if I was to go to x squared plus y squared plus z squared equal a 9, well, that's really a sphere. A sphere, I find it easier to graph this way. That is, draw a circle. And within the circle, try to make those equal. it's easiest to graph a sphere that way. And all what you do, you put the grid in the middle. Oops, wrong grid. And just center it where it matches. There you go. And you say that's a 3, that's a 3, and that's a 3. And of course, the GeoGebra graph looks a lot nicer. Oh boy. There. That's really what it looks like. And what happens if I am to let me see if I could do it that easily. Hopefully I would. That's not working. Okay, I'll graph it again. Not a problem. There's one. Except this time it would be what? Sorry about the mess. It takes a while to get used to this. There. Close it a bit. There. Now it's independent. It's taking me forever to figure this out. So here the difference is it's a solid. Less than or equal, that's a solid. So you would fill inside of this and you just say it's a solid, or this is a solid. This is like a soccer ball. This is like a cannonball. And now if I wanted to write an equation myself, I want a solid cylinder that lies to the right of the XZ plane. So the graph looks like this. Here you don't have to graph it. I want a cylinder, solid, that lies to the right of the XZ plane on the left and on or no, to the right of the X, so to the right of this plane, and to the left of Z equal 5, Y equal 5. So with a radius of 3, what that means, I'm going to go up 3, down 3, right and left. I only want that portion of this, and of course it's a solid. You just say solid, it's fine. How would you do that? Well, let's see. If I am to say x squared plus z squared is equal to 9, that will give me an infinite, right? This will run infinite left and right. If I take y and limit y between 0 and 5, that will work. That would be pretty much, of course you don't need to graph it, but you need to visualize it. But that's really what you need to write. And if I get the graph for that, here I couldn't graph on GeoGebra, so when I told GeoGebra to graph x squared plus y squared equal a 9, it gave me the red. And then I asked it to graph y equal 0 and y equal a 5. It gave me the 5 and it gave me the 0. So if I put the inequality, it's going to only give me that piece, which is what I want. And what if I wanted the solid lower the solid lower sphere centered at the origin with a radius of 3, then what I really want lower. Something like that. And the way I would do that, well, a sphere would be x squared plus y squared plus z squared equals a 9. To get it a solid, less than or equal, but that's going to give me the whole sphere. So if I solve for z, so if I say z equals, let's go with equal, it's easier, plus or minus the square root of 9 minus x squared minus y squared. Keep in mind, if I say y equal the square root of 9 minus x squared, y is always positive. And if I say y equal negative the square root of 9 minus x squared, y is always negative. I'll get the bottom half. In this case, since I want the bottom half, all what I have to do is take that out. And that will work. I could, to make it a solid, I could say let z be between the square root of 9 minus x squared minus y squared negative and 0. Or backwards, right? I could that would be correct. So that would be the actual work that I would show, and that's the kind of graph that you will get with that. The bottom half, and of course all what you have to say, this is solid, or here, if you just tell me this is a solid, I know what you're talking about. And that concludes 12.1.